What is overflow in binary arithmetic? Overflow happens when the result of a calculation is too large to fit in the available number of bits. Let's look at the example. The binary number 1111 is equal to 15. Now, we add 1. The answer becomes 10,000. Notice, this answer needs 5 bits, but the computer has only 4 bits available because the result cannot fit inside the register. Overflow occurs. Remember this rule. For an unsigned n-bit number, the maximum value is 2 to the power of n minus 1. If the result is larger than that limit, overflow has occurred. What is the largest unsigned decimal value that can be stored using 4 bits? To answer this, remember that 4 bits can create 16 different combinations. These combinations start at 0000, which represents 0, and they end at 1111, which represents 15. So the range of a 4-bit unsigned number is 0 to 15. Another easy way to find the maximum value is by using the formula 2 to the power of n minus 1. For 4 bits, 2 to the power of 4 is 16. 16 minus 1 equals 15. So the correct answer is 15. Remember, a 4-bit unsigned register can store values only from 0 to 15. Let's solve this binary addition step by step. The question is, does overflow occur in this 4-bit calculation? We are adding 1010 and 0101 in decimal. That is 10 plus 5. The binary answer is 1111, and 1111 equals 15 in decimal. Now, let's check the bit limit. A 4-bit unsigned register can store values from 0 to 15. Since 15 is exactly the maximum value, the answer still fits inside 4 bits. No extra bit is needed. So overflow does not occur. Remember, overflow happens only when the result needs more bits than the register can store. Since 15 fits in 4 bits, the correct answer is no. What is the largest unsigned decimal value that can be stored using 8 bits? To find the answer, remember that 8 bits can create 256 different binary patterns. Those values begin with 0000000, which represents 0, and they end with 11,111,111, which represents 255. So an 8-bit unsigned register can store values from 0 to 255. We can also calculate the maximum value using a simple formula. Maximum value equals 2 to the power of n minus 1. For 8 bits, 2 to the power of 8 equals 256. 256 minus 1 equals 255. So the correct answer is 255. Remember, whenever you're asked for the largest unsigned value, use the formula 2 to the power of n minus 1. Let's solve this overflow question together. We are adding 11,111,111 and 0000001 in decimal. That is 255 plus 1. The binary answer is 100 million. Notice this result has 9 bits, but our computer register has room for only 8 bits. An 8-bit unsigned register can store values only from 0 to 255. The value 256 is outside that range. Because the result needs an extra bit, it cannot fit inside the register. This means overflow has occurred. Remember, for an 8-bit unsigned number, the maximum value is 2 to the power of 8 minus 1, which equals 255. So, whenever the result is greater than 255, overflow occurs. Let's answer another important question. Which statement about overflow is correct? The correct answer is overflow occurs when the result requires more bits than are available. Let's look at 2 examples. In the first calculation, 10 plus 5 equals 15. The binary answer is 1111. Since 15 fits inside a 4-bit register, there is no overflow. Now, look at the second calculation. 12 plus 6 equals 18. The binary answer is 10,010. This result needs 5 bits, but the register has room for only 4 bits, so overflow occurs. Remember, a carry inside the available bits is completely normal. Overflow happens only when the final result cannot fit into the available number of bits. That's the key idea. Overflow is about the size of the result, not simply about having a carry. During a left shift, when does overflow occur? The correct answer is, a bit shifts out of the left side of the register. Let's look at the example. Before the shift, the binary number is 1011. This equals 11 in decimal. Now, shift every bit one position to the left. Without a size limit, the result would be 10,110. But our register can store only 4 bits, so only the last 4 bits, 0110, are kept. The leftmost one is shifted out and lost because a bit has been lost. From the left side, overflow occurs. Here's another example. Start with 1111. After one left shift, the full result is 11,110. Again, a 4-bit register cannot store all 5 bits. Only 1110 is stored, and the extra one is discarded. This is overflow. Remember, a left shift moves every bit one place to the left and adds a 0 on the right. If any bit is shifted out of the left side, overflow has occurred. What is the difference between a carry and overflow? The correct answer is, a carry inside the available bits is normal. Overflow happens only when the result cannot fit into the available number of bits. Let's start with the carry example. We add 0011 and 0001. During the addition, a carry moves from one column to the next. The final answer is 0100. The result still fits inside a 4-bit register. So, there is a carry, but there is no overflow. Now, let's look at the overflow example. We add 1111 and 0001. The answer is 10,000. This result needs 5 bits, but the register has room for only 4 bits. The extra bit cannot be stored, so overflow occurs. Here's the key difference. A carry is simply part of the binary addition process. It can happen even when the final answer fits perfectly. Overflow happens only when the final answer is too large to fit inside the available number of bits. Remember this rule. Carry is about moving a bit to the next column. Overflow is about the result exceeding the register's capacity. Understanding this difference will help you avoid one of the most common mistakes in binary arithmetic exams. A computer uses an unsigned 5-bit register. Which of these values will cause overflow? To answer this, we first need to know the largest value a 5-bit register can store. We use the formula 2 to the power of n minus 1 for 5 bits. 2 to the power of 5 is 32. 32 minus 1 equals 31. So a 5-bit unsigned register can store values from 0 to 31. Now let's look at the options. 31 fits, 25 fits, 30 also fits, but 32 is greater than 31. That means it cannot be stored in a 5-bit register, so overflow occurs. The correct answer is D, 32. Remember, for an unsigned n-bit register, the maximum value is always 2 to the power of n minus 1. If the value is larger than that, overflow occurs. Which calculation will cause overflow in an unsigned 8-bit register? To answer this, remember, an 8-bit unsigned register can store values from 0 to 255. Let's check each option. Option A, 128 plus 127 equals 255. The result fits inside 8 bits, so no overflow. Option B, 100 plus 10 equals 110. This also fits inside 8 bits. Again, no overflow. Option C, 240 plus 15 equals 255. This is the maximum value an unsigned 8-bit register can store. It still fits, so no overflow. Now, look at option D, 254 plus 2 equals 256. The binary answer is 100 million. Notice, this result requires 9 bits, but the register has room for only 8 bits. The extra bit cannot be stored, so overflow occurs. That means the correct answer is option D. Remember, for an 8-bit unsigned register, the maximum value is 255. Any result greater than 255 causes overflow.